So I guess we're ready to go then. Welcome everyone. You're in the room where we're going to be talking about entity frameworks. So if that's not your topic of choice, you're in the wrong room. But if you are here, you want to hear a little bit about entity framework, that's kind of cool. My name is Chris Klug. I work at a company in Stockholm called Active Solution. I've been working with .NET development or Microsoft development for the last 25-ish years. And having done that, entity framework is kind of one of those things that you end up doing. Not a big fan of it until they did Entity Framework Core, and I think there's a lot of cool stuff in Entity Framework Core that actually makes sense, and learning how to use it makes a big difference. Because we as developers tend to not learn stuff, we just hack away at it and then complain because it doesn't work, because we don't know what we're doing, right? So, before we get started, I just want to say the title for this talk was actually initially Stop Using Entity Framework as a DTO Provider. That got roasted. People started complaining about, wait, can I not use Entity Framework as a DTO provider? It's not what I was saying. If you listen to my talk, that's not what I'm saying. But apparently, I had to redo the title to just a DTO provider because the other thing was apparently too complicated to understand. That read not just the title and you'll get more information. Then on top of that, I have to do this because I ended up in a fairly heated argument on GitHub about this talk. So before I ever did this talk, a guy went online and saw that I was doing this talk for JetBrains Developer Day, and he basically Googled my name, found my GitHub repository, went and found my code, read through my code, and then started a big issue telling me that I was not allowed to talk about this. I did not know what I was doing. People like me are destroying the usage of Entity Framework, so on and so on. And it went back and forth a couple of times with some fairly douchey comments going in both directions. And it basically ended up with the last comment being, you are using Entity Framework wrong. Now that's kind of funny, because to me, that's funny because I got that, and about 2 weeks later, Julie Lehrman, who's like queen of Entity Framework, retweeted my talk and said, I fully support this. And then after that, the Entity Framework core team actually had me on one of their community stand-ups and let me do this talk. So I don't know who does Entity Framework wrong, but might not be me. But I also believe that we have to think about the fact that all code is written in a context. And we as developers, we tend to forget that, or some developers do. It's like, oh, you're doing it that way, you're doing it wrong. It's not necessarily wrong, because every single choice we make in code is a trade-off of reasons that we have around us. I have to do it in this way because of this thing over here that you don't have in your solution, because you have some other constraints that you have to sort of look at, which means that when I go up, and especially when I go up on stage and I show code, I get 1 hour to demo a bunch of stuff. You kind of take shortcuts. That's just the way it works. So I just want to sort of hammer that point in, that what I'm going to be showing you today is very opinionated. It's opinionated because I'm a big fan of object-oriented programming, and I have a heavy influence from domain-driven design. So it means with that background and the type of projects that I work on, which is mostly in-house solutions for systems without a huge load in most cases, I can build it slightly different than I would do it if I was in a high-load web scenario where performance was the most important part as such. So what I'm going to be showing you is a very opinionated architecture. You can disagree with my architecture as much as you want. I don't really care. But the things I'm going to be showing you about what I do with Entity Framework are not architecture specific. So when I show you how to do certain things, they will work in your context as well. You just don't need to bring along all the other garbage that I'm bringing in because of my way of coding. So basically, do it the way that you want to do it, but listen to others, because other people might have knowledge, other experience, other constraints that actually help you in a future project or helps push you in a slightly different direction. So with that out of the way, because of some douche on the internet saying that I don't know how to do AF Core, let's go to the presentation. DTO provider. I put DTO provider in the presentation or in the title, and I just want to sort of explain DTO providers. So DTO stands for Data Transfer Object, right? And if you go in and you look at the definition of data transfer objects on Wikipedia, it says, in the field of programming, a data transfer object is an object that carries data between processes. Between processes. DTOs are simple objects that should not contain any business logic, but may contain serialization and deserialization mechanisms for transferring data over wire. Okay. Most of us can agree on that, right? Well, actually, we kind of need to agree on it because on Wikipedia, and Wikipedia is the source of all truth, right? So if it's on Wikipedia, that's true. I did not ask AI, I went to Wikipedia. AI would have been a completely different story. It also says, this pattern is often incorrectly used outside of remote interfaces. This has triggered a response from its author where he reiterates that the whole purpose of DTOs is to shift data between expensive remote calls. So that is a data transfer object. Now, if we take that and we turn that into C#, a data transfer object looks like this. It has no functionality and basically just no encapsulation, public get set. It's a stupid POCO with nothing useful in there. Very useful if you're sending data from a web service to a client or between two services or something like that. However, if you start looking inside of your application, in this case, we got a web server and we have a database server, and they talk to each other. You would potentially put a DTO in here because it's between two separate processes. It goes over the wire. It needs to be serializable. DTOs make sense. Not here. Because inside of my application, we're inside a process, which means that it's not cross-process. There's no reason for us to have DTOs. We have object-oriented programming that allows us to put functionality and data into the same thing and make our objects actual object-oriented in the way that we want to use them, which is why I'm saying, please don't just use Entity Framework to get DTOs and then manipulate your DTOs. Now, obviously, the response to that is, what's wrong with that? It's like, I've been doing that for using objects like that to access the database for years. Now, I didn't put a name here, but I kind of took that comment from one of my former colleagues because we had an argument about this. And he said, I've been doing this for 15 years. And my comment was, if you've been doing something for 15 years and not changed, you have either found a silver bullet that the rest of us have never found, or you have not followed along with the times. So we're going to look at what's wrong with DTOs, in my opinion, and the way that I do stuff. But we'll start with I've been using objects like that to access the database for years. And this question, why are we doing that? Why are we doing DTOs out of Entity Framework? It's a very simple reason, I think, because if you Google getting started with EF Core, you end up here. This is the Microsoft Docs for getting started with EF Core. You go through this, and it says prerequisites, you need .NET Core. This is old. It probably just says you need .NET now. And then it goes into, this is the way you create a project. Here's how you install Entity Framework. You create your model. And then when you've created your model, you define your entities. Those are very much DTOs. So that's why I think a lot of developers do it like this. Because, as I said before, developers read the getting started with, and then they go, I know this, and they throw out everything else, and they just go on from there, which is actually not that great. Reading the manual actually makes sense. Once in a while, you can save a lot of time of actually just reading docs for a while. And then, what's wrong with it? Yeah, that's a good question. Why do I have two slides with the same thing on it? Okay, anyway. For my first question is, if you do objects like this, where do you put all your business logic? Because where is all your functionality? Where is the stuff that does stuff? Because honestly, I don't believe that you get paid for getting things out of the database and putting the same thing back into the database. That's not what people pay us for, right? And the answer to that is obviously, I use services or commands for that. So I put all of my logic in there. So I read a DTO from the database. I have a service that manipulates the data, and then I persist it down to the database again. Now, I probably offended a lot of people now. How many of you are doing code like that? Or use commands? There's a few brave people that actually are willing to put their hands up, going like, yeah, yeah. It's a way to do it. And I've done that for ages. But Also, it means that we take all of our business logic and we spread it across a gazillion different classes in a gazillion different places, which makes it really hard to figure out what does the application do, what are the rules, what are the business criteria around this type of object. And also, where's the data validation? Because if you only have get sets and data objects, data DTOs, where do you put your data validation? What's the thing that validates the data that goes into the database? Well, obviously, this response to that is I put that in my services and my commands, which is, once again, you spread it out. So if you need to validate that the first name of a user needs to be at least 3 characters, you need to check that in 6 different places. And if it ever changes, you're going to forget one and so on. It makes it complicated. And then you've got this developer that goes, no. Yeah, that was my comment. I put that in a validator class. We've all probably gone through that thing where you have a validator.validate that you take in a thing, and then inside that thing there's a fluent validator. I'm hearing chuckles out here. I think I'm hitting like 70% of people's code bases right now. Sorry about that. This is better because you're basically putting all your validation logic in one place. So you get like validate name, and then if you ever change the name validation logic, you can do that in one place and you're good to go. But you're now forcing the people writing the services and the commands to remember to call that validator. So if you don't do that, your validation logic is useless because, hey, it's never been called. And then you have, that's why we have setters. Yes, you have setters in C#. Why are you not using your setter to do your data validation logic and put it into your object, which is a lot more efficient? And it means that if you put it in your setter, you can never circumvent that validation either. It's always there, and it means that the person that starts using your object doesn't need to know that, hey, I need to call this thing over here. It's here. When I got my user, the user name validation is in my user object. Makes kind of sense. Now, I do want to mention that using setters have a couple of potential problems. How many of you put try catch around setting a property? No one. Because for some reason, .NET developers have gone lulled into this world where exceptions are only thrown from methods. You don't get exceptions from setting a property, which is fine. You're allowed to throw exceptions in properties, but most developers don't actually put a try catch around it, so it might trip them up. But I'd rather have the developer getting tripped up than having incorrect data in my database. Now, for this talk, I have created an example domain, and it's going to suck. I'm going to be honest with that. All of my demos on stage always suck because you got an hour to demo something. It makes it hard. So this is my domain model. It is very small. We have an owner / a person in the middle, and an owner can have one or more vehicles, and a vehicle can belong to one or more owners because you've got history backwards as well. And then an owner / person also has addresses, and they have a delivery address and invoice address. Small domain, still big enough for me to demo what I want to demo. Now, with this, I think most of us would come up with a database schema that looks something like this. We've got vehicles, which doesn't actually have a lot of things. It's just a VIN number and an ID. Connected to owners, which is a connection table that keeps track of from and to when you actually own the car, which connects to people. So you have a many-to-many between people and vehicles with history. And you got people connected to addresses, and addresses have like a type which says invoice or, what was the other thing? Invoice or delivery. Make sense? Now, if we use this domain with DTOs and services, you end up with something that looks like this. So we have this thing here called DTO raw. So basically, you end up with your models being like you have an address DTO, which is just, in this case, a record. You have a name DTO, which is just, I just made them records, which is bad because I can't update them, but let's ignore that. But we have these little model thingies that we pull out of the DB context. And then all of our services, the things that do stuff, no, that wasn't the one. I wanted this one. They all basically go and say, hey, we have get person, well, actually, let's go for one of the things that, here we got one. Set person's address. So in set person's address, we need to do some validation logic about the incoming parameters. Then we need to ask the DB context to get the address. And then we have to verify the person for the address, and then we have to verify that the person is available. And then we look at existing addresses, and oh yeah, there's a rule here that says you can only have one current address of a specific type. And if there is an existing address and you add a new address, then that needs to be reset and set as default or is current to true. Then we create the address, we add it to the address collection. And then there's another business rule in here that says that you're only allowed to, we should only save the last 3 addresses for a person, so we don't get their addresses forever. So a bit of business logic in here as well. And then we go and save changes in here. This unfortunately becomes a muddled mess because we've got input validation, we've got business logic around that thing, we've got business logic around this thing, and everything is in one place. And then if I ever need to do anything with other addresses in another place for some reason, I have to replicate all of it, which is just, it works, and I have written it like that for a long time. It does actually work, but we can do it slightly better, in my opinion, which is why I decided to do this talk. Now, we had a project where we built it like this for different reasons, and it ended up being a lot of code and a lot of services and things like that, and it got hard to work with. And we were like, can we make it a bit more object-oriented? Can we make it a bit more like proper objects? And yes. So I came up with, in this project, I decided that, hey, let's take all of our stupid DTOs and wrap them in another object, which makes them, and I've made this thing, OOPI. I don't think OOPI is a real thing, but you kind of get what it means, right? So I'm going to keep using the word OOPI. So by taking an OOPI object that has all of the functionality that you want, and you wrap your DTO, it means that you can get all of your setter validation, and you can have all of that stuff in one place, and just wrap the little DTO. So what would something like that look like? Well, let's take the vehicle class here, for example. So instead of working with the vehicle DTO and pulling out the vehicle DTO and making changes to it, you have a repository that pulls out a vehicle DTO and then injects it into a vehicle class. And then on the vehicle class, we have methods that make sense, like set owner, and we can get, or we can create it. There wasn't a whole lot more functionality on this one, unfortunately. But it wraps the thing, giving us access to easy-to-use methods. And also, for example, down here, we can look at current owner. We can give the user a property called current owner that goes through the owners list and finds the first one where the to hasn't been set, which is the business rule. And it's easier to use. But it also means that every property that we want to expose becomes one of these vin equals or greater than vehicle.vin. Vehicle, we have to always go through that extra DTO, which is kind of annoying, but it works. So if we go and look at what it would look like to do the same thing that I just did with pure DTOs, and we look at the wrapped version of it, and we look at the vehicle service, and we go and we look at the set current owner. Set current owner becomes this much nicer thing. You basically go and say, hey, context, can you get me a vehicle with VIN? I also made it nicer because I added extension methods to my DB context. So instead of going context.set_of_t.with and all of that, I created extension methods that makes it easier to read. And then we just check, hey, is there a vehicle? Okay, sweet. We check for a person with a specific ID. And then we call set owner. Instead of doing a bunch of validation and all the stuff like that and business logic, we have this method in here, and if we jump into it, it checks the current owner. It creates a vehicle owner entity and adds it as it should. And it also, basically, when you want to end the ownership of the current owner when you're changing owners, instead of having the vehicle class knowing how to do that, once again, it calls the current owner dot end ownership, and that is a method that basically knows how to do that business logic in there. So in the end, when you end up working with this, yes, there's a bit of more work around your entities that you have to kind of craft and make, I don't like to say beautiful code, but you need to make it more like user-friendly and usable. Then when you use it, the person who writes this thing doesn't need to know a bunch of things. The person who uses your class can just go vehicle dot and then look at the IntelliSense menu and say, hey, what can I do on this thing? And it comes up with methods. It's much easier to work with. And if your business rules change, you know where to go and change it. Because if the business rules for a vehicle change, you open ta-da, the vehicle class. Not the vehicle service thingamajig or the 6 other commands or everything. Everything is in one place. But then you start wrapping your DTOs like this, and it quite obviously ends up with this massive question of why. Why in the world would you do this? It's stupid. EF core is an object relational mapper, or ORM. So what is an ORM? I found an explanation online because I didn't want to use my own words. And it says an ORM is, or object relational mapper, is a piece of software designed to translate between data representations used by databases and those used in object-oriented programming. That sounds exactly like what we want, right? It takes something from the database and puts it into the thing that we need in code. Doesn't need to be DTO. So that part is the important. It's meant to translate from one representation into another representation. It's supposed to translate it from the tabular data in SQL to your entity in code, which has all of your logic. So we can map straight to complex objects? Yes, we can, and we can do it really well on top of that. So before I go into that, I took my domain and I took some of the domain-driven development practices, and I basically said, these are actually 2 different concerns. They're 2 different domains, or 2 different contexts, rather. We've got one part which is, hey, I want to look at owners and vehicles, and I will manipulate the vehicles and the owners in one area. But there's another area of the application where I have a person, not really an owner. It could be an owner, but it's a person that has addresses. But I never manipulate addresses at the same time as I manipulate vehicles. They're 2 different things. So in domain-driven design, you end up with 2 bounded contexts, a vehicle management context and a people management context, and you split them out. So this is what I'm going to end up building. I don't know what was the difference here. Okay. Now, the problem with that is that if you want to split this out, you have 2 options. Because, if we go back to this, owner and person are going to be using the same table. They're going to use the people table. And when you use entity framework, you can use the same entity multiple entities for the same table using 2 different ways of solving the problem. One is called table splitting. It's when you tell entity framework specifically that I have 2 entities, they both use this table over here, but you have to define one as being the owner of that table. So you can only manipulate pretty much, or you can only create one of them. But that's fine, because a person will only be manipulated in the people management part of the system, so I don't need to manipulate it in my vehicle management. Or the other way around, so you can use multiple DB contexts, which is a very useful way of doing it. It makes your mapping a bit easier, but it also means that you need to make sure that, well, A, you can't use migrations properly, because a migration only cares about one DB context, which means that you can't do auto migrations because it would only know about the changes in one DB context, not in all the other ones, which would cause, let's call it problems. And the other thing is you kind of need to make sure that only one DB context was ever allowed to write to certain columns, so you actually separate them. It becomes complicated. We have built a project like that. Table splitting is a better solution, even though the mapping is a bit more complicated. Now, an added bonus of actually separating your logic like this is that you end up with smaller chains of objects, smaller graphs of objects that belong together, which means that you probably don't need lazy loading. You can eager load everything if your aggregate roots and all of the dependent objects are a small enough graph. And also, lazy loading is not great, if we put it like that. They didn't even put a lazy loading into Entity Framework Core to begin with, because they didn't actually think people should be using lazy loading, because it causes A, a lot of round trips to the database, and B, also problems when you dispose your context but keep your entity and try to serialize this. It just blows up. So let's have a look at how we can use all of this stuff to actually map my domain into real entities. So I have the code here, and all of this code is available online at the end if you want to have a look at it. But it's fairly simple. I've broken my 2 different domains, or bounded context, into people management and vehicle management. They're their own parts. They're still in the same library. They're using the same DB context. I just kept it small. And in here, you can see that there's a vehicle service, which is the same one that I had before that used DTOs, but it throws not implemented exception. And in the people management, I have a people service in here, which is fully implemented. We will do some mapping stuff in there in a second. And then we have, in the data folder, there's a DB context, which is completely empty, except for a bunch of commented out code. That's interesting to have a look at potentially, because uncommenting that will give you some features, like it will log to the debug output so you can see everything that's being done easily, and it will use query splitting. So instead of getting Cartesian products and joining a bunch of tables, it will actually split your queries into several smaller queries, which helps with data management. But I left that out. It's an empty DB context at the moment. So what I'm going to do is I'm going to start out in the vehicle management, and I'm going to start by adding some entities in here. So I'm going to add a class called vehicle. And because I'm a slow typer, I'm going to go and say that. We're going to have a look at that. Here I have a vehicle. It has an internal list of owners. And it has I made the constructors private, so you can't actually access them. There's a reason for that. I personally don't like constructors. I like factory functions instead, but personal preference. I made 3 properties down here, a VIN, and then I've added those things that I showed previously on a slide that basically goes and finds the current owner based on the owner's list and does all of the searching and filtering in there. So that's my main thing. I've got a VIN in here. DDD has this idea of value objects where you actually turn a simple value, like a string, into a value object. So a VIN is literally just 18 characters, I think, 17, sorry, with a predefined format. By making that VIN, that string, into an actual object, it allows us to verify that you can never create a VIN that is incorrect string. So you never need to validate a VIN string, because once you've created a VIN, we know it's valid, because when you call create on it, it checks is valid, which always checks your regular expression. So you can never get a VIN that's invalid, which means that we can remove a bunch of if blah, 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 because once it's there, it's valid. So I'm going to use that. We're going to move that to another file, like that. We have a little class in here called owner. And the owner is an ID, first name, last name, and from and to when they owned the vehicle. Now, for the astute listener, you look at that and you go, wait, that doesn't work, because that's a combination of, it's a combination of the vehicle owners table and the person table. So it's actually one thing that combines the ID and the name from the people table and the from and to from another table. So we'll sort that out later on. And the final thing is name. I just made name a record as well because of reasons. So we're going to move that as well. OK, so now we've moved all of those. So we have all of our entities. I'm going to need a database. And to create a database, I'm going to create a migration. And I really, for everything, hope that Shai is not around, because when I did this last time, I was told that this is not supported, what I'm doing. It works fine. It broke for a little while, and I complained, and they say it wasn't supported. Then it finally started working again, and now I'm going to ignore the fact that they said it's not supported. I'm writing my own migrations manually. I don't use the EF tools to generate migrations for me, because, I don't know, I have OCD, and I want to control my migrations. So what I'm going to do is I'm going to create a new class in here called initial migration. And for that, I have this little helper thing called EF migration. And I'm going to give it 1. I'm going to call it initial migration. It's going to be demo context. There it is. It's not that hard to write your own migrations. So it solves a bunch of issues with stuff just happening and snapshots and all of that stuff that the EF team probably has a very good reason for having there. But yeah, I don't like them. So first thing I need to do, I need to map my vehicles. So I basically go and I say, create a vehicle table. I'm going to do mapping. So I create a vehicles table. It has 2 columns, a constraint, that's it. I need a people table, once again, 3 columns, a constraint, nothing complicated. I need a vehicle owners table, which is just vehicle ID, person ID, from and to as dates, and then foreign keys added to them. Not very interesting as such. And then finally, we need to go and create some indexes because we want to make the database somewhat efficient. So we put a couple of indexes in there. And in the down, which for some reason I did put in here, I never implement down, by the way, in any situation, because you never roll back. If you roll a migration and it fails, you do another migration that corrects the thing you had before, because rolling back is really, really hard to get to work. And honestly, have any of you got a pipeline that supports rolling back your releases? Anyone? No. Oh, there's one. There are a couple of good people in the crowd that understands that you probably potentially should. But down is hard. So if you just say there is no down, in my current project, whenever there's a down, I think there is a throw new not implemented exception. Chris says this is a bad idea. I did not write that, but another developer did, and it keeps coming in the code all the time. So I'm okay with that. So now I have a migration. That's fine. Now, as I mentioned, the owner is a bit complicated because the owner has the ID, first name, and last name from the people table, but from and to from the connecting table, which doesn't work properly. It can be mapped, but it's complex. So sometimes we have to go and say, okay, because of entity framework, we're going to have to make some concessions. We're going to have to make some changes to accommodate what entity framework can actually support in an easy way. So in this case, what I am going to go ahead and do is I'm going to go and create a person object like that. And then actually, well, yeah, I think I'm going to have it here. No, actually, I think I can put it, let's put it in here. No, I can't put it there, sorry. I need to put it in here. I thought I could hide it. I don't think I can. So let's put it there, and we'll move that into another file. Once I have a person, I then update my owner class here. We're just going to go and say EF08. So what I do is I create an internal, a private field with a person in there, and kind of like the wrapping of the DTO that I did before, and then I expose ID as person.id, and I expose name as person.name. Now, this looks slightly odd and maybe not as beautiful as the previous version, but it really doesn't matter because the person using this is going to go and say, hey, I need an owner, and the owner class will look exactly like we want it. The fact that there are some implementation details that are EF core specific, that's just the way it is. Okay. Now we have our entities, we have a migration. Now we need to tell the DB context that we want to map our entities. And that is done inside of the on-model creating, right? So I'm going to start with my vehicle mapping. So I'm going model builder entity of T, in this case vehicle. I'm going to say map it to vehicles table. Actually, I don't even think I need to do that because the convention is it takes the name of the class plus an S at the end to make it plural, and then that's the name of the table. I like putting it in there because it's explicit. Because honestly, if I ask everyone I know, if they know all the conventions in EF, nobody's going to say yes, because the conventions are many and they're complicated. And if you got a new person coming in or you got a junior developer on your team, they're going to look at it and go, why does this, no, you don't understand because you haven't learned all the conventions. Being explicit makes it a little bit easier. Then I map this thing here. Property of int ID. Now, interesting enough, if I go to vehicle, vehicle doesn't have a property called ID. There's no field called ID. There's nothing in here called ID. But we need the ID, not in our domain, because the natural identifier for a vehicle is the VIN. You always work with VINs. You don't work with IDs. But we need the ID because we're mapping in Entity Framework everything based on IDs. When we do foreign keys, it's based on the ID. Now, using property of int with a string tells Entity Framework that I want to map an integer, I want to call it ID, and if it's not available on the class, make it what's called a shadow property, which basically means keep it in EF and let me use it for doing queries and stuff like that, but it doesn't need to be part of my domain or part of my code, which is really nice. Then I tell it that I have a property of type VIN. Now, I'm going to come back to that because that doesn't work. Ignore that for now. Then we have an has many, and because I'm using has many of T and I give it a string, it will look for either a property or a field with that name. And in this case, if we go to the vehicles, you will see that there is a field called owners. It is case sensitive, by the way. But it will find that field, even though it's private, and map it to a private field. So mapping private fields means that you can hide stuff. Encapsulation is a core tenet of doing object-oriented programming. I also go and I find the owners navigation. I do auto include because I always want to bring in the owners for my vehicle. Maybe not a great idea because it's an unbounded list that might actually grow to be humongous over time, but it's a demo, so it's fine. Then I tell it to ignore current owner and previous owner because if we go to those, they actually calculated fields or properties, so Entity Framework can't actually set them. I was told that you don't need that by the EF team, but you do. It doesn't actually figure that out. It didn't in the last few versions that I tried at least. And then I tell it that, hey, you have a key called ID, and it's using the shadow property for my key, so that works fine. Now the VIN is a value object, and because of that, it's a type, and Entity Framework doesn't know how to work with VINs. If you run this now, Entity Framework is nice enough to say, I don't know how to map that for SQL. If you have a database that supports VINs, that's a different story. And it's like, no, we don't have databases that support VINs. That's just not a thing. So we have to tell Entity Framework how to work with this. And there's this cool thing called hash conversion. And in hash conversion, you give it two callbacks. The first one is well, actually, no, well, kind of that, but not really. Whoops. The first one is, how do I convert a VIN to something that Entity Framework understands, which is string? So I take a VIN and I return VIN.value. And the other one is, how do I take a string and turn it into a VIN, and then I just do VIN.create. Because of that, I can now actually query VINs. I can actually tell Entity Framework, find anything with this VIN and give it a VIN, and it will then use this conversion to get the string and actually map everything properly for you. So value objects work fine in Entity Framework, which is kind of nice. We also need to map our owners, so we'll do owner mapping. Not a lot of interesting stuff in here. It's kind of the same thing as I did before. It does a private field mapping of person, it does a shadow property of vehicle ID, and it puts a key, multi-part key for vehicle ID and person ID. The only thing worth mentioning here maybe is that for me, I have a naming convention here, by the way. If you're doing a shadow property, or if I do a shadow property, I use Pascal casing, so capital first letter. If it's a private field, it's going to be camel cased inside of your code, so then I use camel casing here. So if I look at my mappings, I can figure out, oh, this is a shadow property, or this is a private field. And anything that is an actual property, I would map using this syntax down here, the Lambda syntax instead. Then we can go ahead and we can map my person. Person is also very simple. It maps to table, and I'm okay with the convention that says if the column name is the same as the property name, then it just marries up. I don't need to define every property. And I go and say, hey, I have a complex property in here. Complex property says that I need to map, in this case, it maps a person. Sorry, it maps a name, like that. And it's just saying that I have an object called name. It has a first name and a last name, and I'm making it a complex property, which allows me to save the first name and last name in two columns in the same table, instead of having to get it from different places. So complex properties allow you to map multiple columns into one object in your code. Okay, that's all the mapping that we need to get my vehicle stuff working. Now we can have a look at the vehicle service. So let's start with get vehicle by VIN, which is my first little option here. Let's have a look at how that looks. So because I have this VIN.tryCreate, my method takes in a string of VIN. Then I do VIN.tryCreate. If that doesn't work, I fail my method and I return a failure and say, hey, it didn't work out because there's an invalid VIN exception here. Then I need to pull out my vehicle, and there are multiple ways of doing this. Repository pattern is really popular among C# and Java developers. That's one option. It was just too much code. So I'm going to kind of just fake it a little bit. So I'm going to go ahead. I'm going to pass in the demo context here. And I could go ahead and say context.set of t, but I'm going to make it a little bit nicer. So I'm going to go ahead and I'm going to add a new folder in here. I'm going to call it data. inside the data, I'm going to add a class called demo context extensions, like that. I'm going to replace that, as far as I remember, with this. So it's a static demo extensions class that extends the demo context here and gives me get vehicle with VIN. I pass in a VIN. It creates an iQueryable and then returns first to default based on that, which basically means instead of having to use a repository pattern, I can simply go await context got vehicle with VIN, and I pass in V, which is my VIN, exclamation mark because it's nullable, and true because I want it as no tracking. It's a very simple way of doing like a repository-like thing. The only thing is you can't cache and you can't do a bunch of other things you can do with a repo like that. Second part here is that this thing actually returns a DTO. Another convention for my architecture is my services will work with entities, but they will return DTOs, so they're ready-made to be sent back to the user from the API that's going to be calling it. And the way that I fix that to make my vehicle class or entity to become a DTO is that I'm going to go ahead and add another extension thing here called DTO extensions. And I'm going to use EF14 for that. All it really does, it has two extension methods called toModel that extends vehicle and owner, and it just creates these stupid DTO objects for me so that whenever I want to go from an entity to a DTO, I can just go to model like that, and I get the DTO instead. So it becomes a very clean sort of implementation of my service here. Next thing to have a look at is get vehicle by ID. Now get vehicle ID is, that was not a role I wanted. I wanted to use that. It's not very complicated, except for a few things. So first of all, I need a vehicle with ID thing in my demo context extensions. So go in here and say EF16. Now, how do I go ahead and pull out a vehicle by ID if my vehicle doesn't actually have an ID field? It's a shadow property, right? Now, EF has a really cool thing that can be used for a lot of things. There's a static class called EF. If you go ef.property of type int, whoops, I want to get a property of type int for my entity called X, and the name of the mapping is ID. And then I say equals ID. So even if it's a shadow property, you can query it. Even if it's a private field, you can query it. So in your queries, you just do EF property of T, and then you can start going at your private fields or your shadow properties and make your queries useful as well. So that's kind of sweet. That means that when we go out here, all we have to do is nothing else. That's done. Get vehicle with ID works. Next one, well, let's go ahead and go get current owner by VIN. Now, get current owner like VIN is fairly similar to everything else. It looks for, tries to create a VIN. It gets the vehicle, and then it looks for the current owner. If there is no current owner, it throws or returns an owner not found exception. Otherwise, it returns the current owner. Now, this is obviously, if you're in a high load scenario or you're caring about performance, this kind of sucks. Because you're pulling out a whole vehicle when all you really need is the owner. So you're pulling out extra data. And in this case, it's two very small objects. But if you're working in a bigger domain, you might be pulling out large amounts of data to pull out a little thing down at the bottom. So we can make this a bit more optimized by saying this. So I go set of vehicle, then get any vehicle where the VIN equals V, then do a select, use the EF property to pull out a collection of owners in the private field called owners, and then I want the first or default one where 2 equals null. That will give me the current owner for a vehicle. And then if the owner is null, I return owner not found exception. This doesn't work because I've just changed the behavior of my implementation, because it would return owner not found if the VIN doesn't exist either. This first one here would actually say, hey, vehicle not found exception if the VIN wasn't available, but owner not found if there was no owner. Now, we can make this better and actually get both of those by saying this. We do set of T, vehicle, where VIN equals V. Then we do a projection. So we basically say, now that you've found the vehicle, can you please give me the VIN and the owner based on the owner's field, and then return the first or default of that. And then the vehicle projection returned here would be null if there is no VIN, because that's part of the where. But if there is a VIN, I can then look at the vehicle projection.owner to find the current owner, and that means that I'm doing a very efficient call to the database. Instead of pulling out lots of stuff, I'm pulling out exactly the things I need. Make sense? Your code gets really ugly when you start doing this. But it's better from a performance point of view. And I'm currently working with a project where everything is dynamic. So we join 72 different things in weird ways. And you kind of have to write these queries to make it work. Now, let's look at add vehicle. That's also fairly simple. It, once again, goes VIN, try create, gets a vehicle with that VIN. If the vehicle exists, then I throw an exception because you can't have two vehicles with the same VIN. Then I get the person with ID. That doesn't exist. So we kind of have to go and add that in here. Nope, that wasn't what I wanted. I wanted EF19, which is just a quick query that allows me to do person with ID. And then instead of going new vehicle and using the constructor, as I said, I prefer using factory functions. So if I go to vehicle, I can then go in and add a nice little create thing in here, which then takes a VIN and a person as the owner, creates a new vehicle and adds an owner class based on the person that I just passed in, and adds that to my list of owners as well. So that becomes a nice little easy to read thing as well, very simple, step by step, this is what we need to do. And then finally, the last one we've got to implement is set current owner. So if we go EF21, once again, there's a lot of repetition in here. You could probably refactor some of this, but we got check the VIN, get the vehicle by VIN, get the person with ID, which is the new owner, and then you go set owner on vehicle. So if we go to vehicle, we can now encapsulate that logic in here, which is basically if current owner, and then it sets the current owners with to end relationship or end ownership, or it creates an owner and adds it. And then on current owner, which is an owner, we need to add that EF23. We need to add that method end ownership. But it means that we're now asking a vehicle to change the owner, and it owns that responsibility of doing that instead of having other things poking at it and saying, this is what you need to do, which is nice. Now, that's actually everything needed for the vehicle domain. The people domain is obviously going to be a lot of repetition, which is why I've already implemented most of that. So if we look at the people domain in here, we already have a name class. We have a person class. The person has addresses. Address is actually an abstract class that is inherited into delivery address and invoice address, so that we can do address is delivery address, address is invoice address, for example. And we have a person service that is fully implemented as well. So all I need to do is the actual mapping of this. Now, the thing we're missing is the address stuff in the database. So I'm going to need another migration in here. So let's do address migration. That's going to add another EF migration in here. I'm going to call it 2. Address migration for the demo context, like that. And in here, we'll go ahead and create this. It's basically just one table that we're missing. We're missing the addresses table. And it basically it's got address line 1, 2, postal code and everything, and a type that defines whether or not it's a delivery address or invoice address. And then there's a person ID that's connecting it to a person, and then there's an index and a foreign key to the people table. And then once again, because of reasons, I apparently implement down, which is drop table. That's it. Now, to map this, we could go ahead and go into the DB context and keep adding things into on-model creating. Now, you can quickly realize that if we keep adding things to on-model creating, we're slowly going to make on-model creating a behemoth of code that's going to be complicated to maintain and annoying. So I wouldn't recommend that. Instead, inside of the people thing, inside the data folder, I'm going to go ahead and add a new class. I'm going to call it person type configuration, like that. I'm going to replace it with this. So it's a class that inherits from entity type configuration, I entity type configuration of person. I entity type configuration of person has a configure method with an entity type builder of person. And then in here, I can add my migrations or my mappings. So I'm just gonna, that wasn't what I wanted that. So I put the same type of mapping that I would do in on-model creating, but I put it in this class instead, and there's nothing new in here as such. And then I need one for my address as well, so that has a bit more information in it. So we'll move that to another file. And that, the only thing that's interesting in here is that it looks at, it maps a shadow property called type, which is going to be the type string in the database table. And then it says, if the type column has this string here, delivery address, I want you to map it to a delivery address. If it's an invoice address in that column or that string, I want you to map it to this. And then you can go ahead and map other things on it as well. So right now they're identical, but I could then go and say, oh, on the delivery address, I want you to map these other fields. And on the invoice address, I want to map these fields. So you can then basically have it go nice type hierarchy in the same table, which is nice. Once I have my type configuration in my on-model creating, I can go and say model builder dot apply configuration from assembly, and we pass in get type dot assembly like that. And it's actually going to go and find all I entity type configuration of T and run them for you in a non-defined order. So if you have anything that requires order, which you generally shouldn't have to according to documentation, but in the real world, order actually makes a difference once in a while. You can't use this. But for a lot of situations, you can just run that, and we could translate these into the same thing, and it would just be a one-liner. Now, that's all of the mapping that's in place. All we need to do now is basically verify that my code works. So let's go ahead and build this. Let's go ahead and build this. Then we go to this thing here. And we kind of do the little happy dance, saying that it should find my, pray to the demo gods that it should find my tests. It did. So here are my tests. So let's go ahead and run all of my, it did not find my tests. That's bad. Why did it not find my tests? This thing is .NET 9. It's a test project. Why is it not finding my tests? Let's try building that one more time. Build completed. Okay, let's try this. Oh, okay, let's try this. Tests. It found those tests, but it's not my tests that I want. Oh, because I was about to say idiot. I'm not supposed to be demeaning myself on stage. But if you go in and actually uncomment the tests that you want to run, they might show up in your test explorer. Now you've learned that as well. So not only did you get EF core knowledge, you got unit testing knowledge as well. Let's go in here. Here they are. My domain tests. They're in here. Let's run them. I have 6 minutes to get this to work. So no, not debug. Well, no, actually stop. Well, let's not do debug. Let's just do run these tests. There we go. This is going to go and create a database for me and run it, and it goes, no, it didn't work. And then we go in here and we look at the error, and it says, no suitable constructor found for person, name, blah, blah. Now, this error message is a bit hard to understand, but the reason is because I did map the person class in both of the bounded context to the same table, they default to prefixing the column names with the class name. So it expects it to be person underscore blah, blah, blah. So the fix for this is you go into DB context, and where you map your name for the person down here, the complex property here, if you take that and you replace that with this, let's do this. So we have to tell it, I have a complex property, but I have to set the column names manually because of conventions. I wish I could turn off some conventions, and you probably can in some way, but it's just, Let's leave it like that for now. And then in my people management, where I have my person type configuration, I need to do the same thing. So I'm going to do EF29 in here and do the same thing to tell it, hey, these are the columns names that you should use. Let's run it again. Another error, cannot use table people for entity type person because, since it's being used for entity type person. Yeah, okay. It is because I have a person type configuration that defines the people management person, but I also have a person class inside of my vehicle management that use the same table, and they're mapped to the same thing. That doesn't work. So in the main one, the thing that, in quote, owns the actual table, I have to go in and add this fantastic thing that I need to write an extension method to remove, because you go, person has one person with one has foreign key person ID. Makes no sense. Has one with one, pointing at two different entities, pointing at an ID. It's basically saying this entity here has a sort of a sibling thing mapping to the same table, and they both share the key ID. If you do that, which by funnily, when I showed this at the EF Core community stand-up, they said, that doesn't work. I'm like, yeah, it works. No, that can't work. And I showed it works. And they go, that's not supposed to work. It's like, it's documented on your website. It is in the docs. You can actually find this on Microsoft Docs. Now, the last thing that fails, because everything else works, says values differ 1 minus 1. If we go to this, the reason for that is that it looks for the ID of the DTO that gets returned back. If we go to the DTO for the person for this thing here, DTO here, nope, apparently not, inside this one. Sorry, I'm in here that I want to look at it, and no, I want to look at it inside this one, in here, in that thing. Because I pass in the ID for the person DTO is hard-coded to -1, which is not what it's supposed to be. It should be the ID. Now, the problem here is that if I go to person has a private field called ID. I don't want to expose that because I don't want people to use ID. Now, I have a way of fixing that I enjoy. Not everybody does. Some people have told me that I'm an idiot. But I create an interface called I have ID of T that exposes ID of T. If I move that to, actually, I need to go up here and do refactor, move to another file. I just move that. I close that down. Then on my person, I say, I have ID of int, like that. And then you go and say, implement missing members, and it adds that. And then you go, but Chris, you just added ID. What does the interface do? I'm not done. What you do is you remove the public. You say, I have ID of int dot ID returns ID, which basically gives me explicit implementation of the interface. So unless you know it's there, you can't use it. And if you then go to your DTO extensions, I know now that a person implements I have ID of T, so I can say I have ID of int for person, and I cast my person into that, and then I can ask for my ID, and I'm not, nope. It's hard, parentheses are hard. That should be it. Now it means that anybody using the person class won't see the ID, but I can still access it whenever I need it. And if I run my tests with 1 minute and 23 seconds to go, 21, 20, 19, 18, 17, they're all green. So mapping works. So I've not shown you that you can actually map into real object-oriented style. You can do private fields. You can have shadow properties. You can map all of these things if you just learn how to do the mapping properly. So my recommendation in the last minute would be map objects to the way that you want them to look. Like I always start out with writing the entities in the way that I want them to look. And then, oh, so this API makes sense. This is the way that I want to use it. And then I go, how do I map this with Entity Framework? And in some cases, I have to make some concessions and basically bow to the will of EF. And in most cases, it works. I also ignore or don't use lazy loading because I try to have aggregates and aggregate roots that are giving me small enough graphs to actually do auto-include. And I have a way to solve lazy loading that I will demo at some point that doesn't use lazy loading but uses interceptors and stuff. So I try to get away from lazy loading whenever I can. And then obviously if you have performance problems, then go back and do queries specific like queries like I did with the projection and all of that makes your queries more efficient. And also look at splitting queries. So split queries allow you to get away from Cartesian products. And finally, this is a micro thing. They always map both the ID and the entity, and they always map them in 2 directions. I hate that. I want to have a directional relationship from entity A to entity B, not back again. And I always use the entities and not the IDs, because setting an ID and then going save changes means that I haven't verified that the ID actually exists. Using the entity means I have to pull out the entity first. I can verify that it exists and then do the work for me. And also, don't migrate your database as part of your application setup. I'm not going to show you that demo because I'm a bit long, but basically, you can pull out SQL scripts from Entity Framework, and you can even pull out an executable that will do your migrations for you, which is really nice. All of the code for this is available at that address. Use the bit.ly QR code, because I think those are supposed to be lowercase, like I mentioned to the people in my room yesterday. I want to thank you all for listening. Please don't forget to do the evals. There are a bunch of green things out there. Those are the ones you want to put into the little bowl. I would appreciate it so much. If you have any questions, feel free to grab me at any point during the conference. I will be outside. Thank you so much.